Hello, this is Mr. Best. We're going to be looking at homework questions 3-6 to 3-11. 3-6 says use what you have learned about exponents to rewrite each of the expressions below, and we need to simplify them. So we'll start with question A. We have h to the 9th divided by h to the 11th. So we could expand this out 9 times in the numerator, and then the denominator we can do it 11 times. Now that does take some time to do, so if we also think about this, we could rewrite this as h to the 9th over h to the 9th. That gives us that value of 1. But we still have 11 h's on the bottom, so we have 2 that we have to account for. So h to the 9th divided by h to the 9th is 1. 1 times 1 over h squared is equal to 1 over h squared. Next up, B, we have x to the 3rd times x to the 4th. So we could expand that out to x times x times x times x times x times x times x. So you can see there's a total of 7 x's. So that's x to the 7th power. C, we have 3k to the 5th squared. So once again, if we expand this out, that's 3k to the 5th times 3k to the 5th. We could also expand that out, but hopefully as you guys are working through these, you can see some of the properties that are happening. So 3 times 3 is 9. And then you have k to the 5th times k to the 5th. So if you expand that out, you'll have 5k's and then another 5k's, which give you a total of 10k's. Moving on to D, we have n to the 7th times n to the 1st. So that would be n to the 8th. Let's see, on E, we have 16 times x to the 4th times y cubed. And we have divided by 2, divided by x to the 4th, and then divided by 1, since there's no other y values. So 16 divided by 2 is 8. X to the 4th divided by x to the 4th is 1. So we have 8 times 1 times y cubed, which would be 8y to the 3rd power. And then the last one we have is F. We have 4 times x. And once again, I'll expand this one out. Times y 3 times 7 x squared, so x times x, and then y to the 3rd. So when you expand this out, you can see that we have 4 times 7 is 28, and then we have x to the 1, 2, 3, so that's x to the 3rd, and then we have on the next one y times y times y times y times y times y, so that will then be y to the 6th power. So 28, x to the 3rd, y to the 6th. Alright, so that's 3-6. Moving to 3-7. Gerardo is simplifying expressions with very large exponents. He arrives at each of the results below. For each result, decide if he is correct and justify your answer using the meaning of exponents. So on the first one, he has x to the 150th power divided by x to the 50th, and he says that is x to the 3rd power. Is he correct? And then we need to justify your answer using the meaning of exponents. So on part A, if we have x to the 150th divided by x to the 50, if we can show our work here, we have x to the 50 over x to the 50 times x to the 100 over 1. So that would be 1 times x to the 100. So we should get an answer of x raised to the 100th power, and you can see that it looks like he divided 150 divided by 50 to get x to the 3rd, which is incorrect. So for each result, decide if he is correct and justify your answer. So on part A, no, he is not correct. So he's not correct, and the reason is we showed our work up here as to what the answer should have been. On B, we have y to the 20th times y to the 41st is equal to y to the 61 is what they have. So what do we do when we're multiplying? If you think about this, you're going to have y to the 20th, so y times itself 20 times y times itself 41 times, so that gives you a total of 61. So on that one, yes, he is correct, because we need to add the exponents. And then on C, we have 2m squared into the 15th raised to the third power. So if we expand this out, we are going to get 2m squared into the 15th times itself 3 times. So what happens? Well, 2 times 2 times 2 is 8, so we can already see that that answer will be incorrect because 2 is being multiplied itself 3 times. And then m squared times m squared times m squared, so that's a total of 6 m's. So that part looks like he's correct. And then into the 15th times into the 15th times into the 15th, so that gives you a total of 45 n's. So that should be our final answer. So therefore, based on what we see his answer is, he had 2 instead of 8, so this is incorrect. And our work is up there. Alright, on the next one here on 3-8, we have a review question. Use what you know about slope and y-intercept to graph. So what do we know about slope and y-intercept? Well, we know the slope is what's being multiplied by the x value or the coefficient. So that's negative 1/2, and we know the y-intercept is the starting value, which would be at 3. So we would graph 0, 3. And since the slope is negative, we need to go down 1 and to the right 2 from my y-intercept, and we can do this a couple of times. You can also go up positive 1 and to the left 2, as long as your slope, make sure, is going down. And then graph your line through the points. Make sure you include arrows on the line as well. Alright, we're going to move on to 3-9. 3-9, write an expression to represent the given situation. Be sure to define your variables. Sam currently has $150 in a savings account and is saving $10 per week. So we need to write an expression, not an equation, expression, to represent the given situation. We need to define our variables. So Sam currently has $150 in the savings account and is saving $10 per week. So our unknown is the number of weeks. So we will say W is equal to the number of weeks. And our expression, we have a starting value of $150 and saving 10 per week. So this is our growth, how much it is growing. So what do we have? We have $10 a week plus the starting value of $150. And that's the expression with W equaling the number of weeks. 3-10, find f of negative 3 for each function below. So once again, a review question here. We're looking at functions. And for each of these, we are going to plug in f of negative 3. And just a quick recall here, remember, negative 3 is the input, and we're trying to find the output for each of these equations. So A, if I plug in negative 3, I will get negative 2 times negative 3, which is 6. 6 plus 3 is 9. So f of negative 3 is equal to 9. B, we have f of negative 3 is equal to the opposite of the absolute value, 1 minus negative 3. So as we simplify here, we get the opposite of the absolute value. 1 minus negative 3 is 1 plus 3, so that's 4. The absolute value of 4 is 4, and then the opposite of that, there is negative 4. So f of negative 3 is equal to negative 4. Alright, C, f of negative 3 is equal to the cube root of 9 times negative 3, and then plus 2 on the outside. So we have the cube root of negative 27 plus 2. And the cube root of negative 27, remember, you're asking yourself, what number raised to the third power is negative 27? And so that would be negative 3. And negative 3 plus 2 is negative 1. So f of negative 3 is negative 1. And then for the last one, D, we have f of negative 3 is equal to 1/2 x. But in place of x, we're going to put a negative 3 and then plus 2. So half of negative 3 is negative 1.5, or negative 3/2, plus 2. So negative 1.5 plus 2 is 0.5. And so that is it for 3-10. That's your function notation and being able to evaluate functions. And then our last one here, I'm going to move up to 3-11. Last one is simplifying each expression. So once again, a review question dealing with fractions on this one. So A, we have negative 1/2 plus a negative 1/5. So when we're adding fractions, we need to find a common denominator. So in that case, this would be 10 multiplying both of these by 5. So 5 in the denominator, 5 in the numerator, which is a value of 1, 5 divided by 5. And then this one gets multiplied by 2, so that's plus negative 2 over 10. So now that you have a common denominator, what is negative 5 plus negative 2? And that is negative 7. So it's negative 7/10 for part A. Part B, we have negative 2/3 minus the whole number of 2. So 2 over 1. Once again, we can find a common denominator. So we have negative 2/3 minus, multiply top and bottom by 3 there. So that'll be minus 6 divided by 3. So once again, you have negative 2 minus 6. Negative 2 minus 6 is negative 8. So negative 8/3. You could change that to a mixed number if you wanted to, negative 2 and 2/3. Alright, moving to C, we have negative 1 and 2/3 being multiplied by negative 2. So on this one, I would take the mixed number, change it to an improper fraction. Now, this whole thing is the mixed number, so we don't include the negative when we change it. 3 times 1 is 3. 3 plus 2 is 5, so that's 5/3. So 1 and 2/3 is the same thing as 5/3. So negative 5/3 times negative 2, or negative 2 over 1. So 5 times 2, or negative 5 times negative 2 is a positive 10. 3 times 1 is 3. So your answer is 10/3, or if you wanted to rewrite it, it would be 3 1/3. Either one of those are acceptable answers. And then on D, we have division. Negative 2 over 1 divided by 2/3. So when you divide, you multiply by the reciprocal. So we're going to change this to 3/2, and we're going to change it to multiplication. And so we either can multiply straight across, which would give us negative 6 over 2, and you could simplify that. Or you could cancel any common factors. Either way, you'll get a negative 3 as your final answer. So here's a little bonus to the video. Why do you divide? When you divide, do you multiply by the reciprocal? If I write it this way as a fraction divided by a fraction, if I multiply by 3/2 to the top and bottom, which is a form of 1, it cancels your denominator out. That'd be 6 divided by 6, which is 1. And then look what you have on the top. You have negative 2 over 1 times 3/2. So that's why you multiply by the reciprocal.